This video will cover developing a surface from USGS elevation data. My name is Seema Shah-Fairbank and I'm a professor at Cal Poly Pomona. The purpose of this is to help students create a surface that can later be used to create a channel alignment and cross sections to be used in HECRAS. The learning objectives for this segment is how do you obtain USGS DEM data? How do you use that data to then create contour lines? And how do you convert those contour lines into surfaces? The first step in this process is to go to the Viewer nationalmap.gov basic. The website is where we can download our data. For this particular project, we're going to be located in Pasadena, California. So when you guys were looking at it, it probably was zoomed out. So go ahead and type in Devil's Gate Reservoir. Devil's Gate Reservoir is located right near Pasadena, California. We're going to be selecting the elevation product, and we want the 1/3 arc-second DEM. And we're also going to pick imagery. We want to know what it looks like in the area. So go ahead and click Find Product. What you will notice is you will see results. First, you can actually see a thumbnail of the raster DEM data. In addition, you can also see the location or footprint of the image file, and as you can see, it's much smaller. Go ahead and download both these files. So under results, you'll see download. Down at the bottom, go ahead and save it as, and place it where you would like to keep your files. I created a folder for Arroyo Seco because that's the project I'm going to work on. In addition, go ahead and download and save your imagery file. While this is downloading, go ahead and go in and open your ArcGIS ArcMap program. It may take a few minutes to load. You should now have your two files saved in a folder. Go ahead and extract your zip file. So you need to extract the files that are in this folder. Once this is complete, you should have a folder that says GRDN 35W119_13. That's the file we are going to copy into GIS. So go ahead and copy that file into your GIS like I am doing. So just drag it. I'm going to minimize this. You'll be asked if you would like to build pyramids. Go ahead and say yes. This step may take a few minutes, and you could see the time on the bottom. And during that time, I paused the video for a few minutes, but now you should be able to see your raster data. What you'll notice when you put your cursor on any point within the raster, down in the corner, it's giving you the data in decimal degrees, and we're going to need to change it. We also need to change the projection of the data so that we can utilize it. So under the layers, we are going to right click and go to properties. Within the properties, you will have a general area. Where it says general, change that to feet. Next, you need to go to your coordinate system. For your coordinate system, go ahead and scroll all the way to the bottom. It should say projected coordinate system. Since our project is located in California and the USGS map information tells us we need to be converting it to state plane, and where our project is located in LA in California, we're going to go to state plane. We're going to then choose NAD 1983, 2011 US feet, and we're going to go to California 5, and that designates the Los Angeles area. If you hit transformation, you can see what it's doing. It's changing it from North American to NAD coordinate system. So just hit OK, hit apply, and hit OK. The next, you're going to right click on the data itself and go to properties. When you go to source, what you'll notice is the cell size is still quite small. So what's happened is though you've converted the projection, it has not converted the cell size into the US customary units that you want. So what we're going to do is there's two different ways to do this, but we're going to use the times calculator. So there's a search button. Go ahead and type in times. You're going to want to make sure you choose Time Spatial Analyst. If you get an error message that doesn't allow you to open the Time Spatial Analyst, remember to go under Customize and Extensions and turn on the different extensions you need. And for us, we're going to be using Spatial Analyst, so that's why that's the only one I've turned on. For our inputting raster, and it's okay if you get a error, for your inputting raster, I'm going to be using the GRDN35W. What I'm timesing is the Z direction of my raster. The data of my raster is actually in metric units, and so I need to convert this to English units. So what I'm going to do is I'm just going to type in a search engine 1 meter to feet, and inside I'll get the conversion. It'll say 3.2808399. I'm going to copy it, and inside my raster, inside my times, I'm going to place that number. Now, I want to save all my files in the same spot, and so you may be asked to map the location. So there's a plus button here, and you can find where you want to save your files so that you're not having to worry about where all your files go. This way, if you walk away and want to come back, you can. I'm going to call this my times, just so I know what it is. And don't hit OK yet. Go to Environments. Environments is where we're going to set our coordinate systems of our output and change our grid. Under Output Coordinate System, make sure you change this to as specified below. Where there's the hand with the paper, we're going to actually choose that projected coordinate. So projected coordinate system, state plane, NAD, and we're going to find California 5. OK. And it should populate. And we're going to hit OK. And we'll hit OK. And this may take a few minutes, and you may not even realize GIS is doing a process. Sometimes there's a progress bar working, and other times they're not. But please give it anywhere from 2 to 5 minutes to process. I'm going to pause the video, and I'll return when mine is completed. It took about 2 minutes, and at the bottom you should see a little hammer with a check mark that says your times calculator worked. If you got an error message, sometimes the path of where you're saving your files is too long and thus giving you a mistake. Now that we have our times raster completed, we have now completed our Z direction, or the height, the elevation. If you right-click and go to Properties on your times, what you'll notice is now the grid size is approximately 30 by 30, 30 feet by 30 feet, which is what we are looking for. It's slightly greater than 30 feet because of the coordinate system. The next thing I want to do is I actually want to clip out the data. I don't want all of LA County. So the same way as before, when I dragged in my GRDN files into here, I want to drag in my image. And so my image is this JP2 file. So copy that in, and when you copy it, place it at the very top of your layers. This may take a few minutes since the file is quite large. When you minimize or move out the Explorer, you'll get a message about your coordinate system. The image is in a different coordinate system than your other data. So we're going to want to do the transformation. And this time what you want to be able to do is notice that the data is in GCS WGS 1984. And we're going to switch it into the GCS NAD 1983-2011. You shouldn't have to look for it again since we've already set it. So hit OK and hit close. And your image is now brought in, and you notice it down in this corner of your project site. Next, with processing contours, I do not want to have so much data. So I'm going to go ahead and clip my data. So under this search, I'm going to type in clip. Clip is how ArcGIS crops the information. So since this is a raster that we want to clip, we're going to use Clip Data Management Tool. For your inputting raster, make sure you select the times. For your outputting raster, make sure you select the image. What you'll notice is that the information about the rectangle changed. You should be good. You could make sure you set the location of where you want to place it, and it's going to the right location. We can say times clip, hit save, and hit OK. And it again is hitting clipping, and it took a few minutes and it's done. And do you guys notice something popped up? So one way to make sure it worked is you can turn off the other data you're no longer using. So the GRDN, let's uncheck it. The times we can uncheck, and now we only see the raster. If we uncheck the raster, we'll see the image, and if we recheck it, we'll see the raster. So keep the raster on and turn off the image. Our last step in GIS is to create contours. So type contour in our search. And we want to create contours from the raster. We're going to use the Spatial Analyst tool. Our inputting raster is our times clipped. We want our output to go ahead and be placed in the same place we've been saving all our files. So make sure we're in River Mechanics. And we're going to call this contour and hit save. Our intervals, we're going to say these are 40-foot intervals. You could choose 5, you could choose 1, and it depends on the accuracy and more of processing speed. I'm going to hit OK. It's doing the contours, and now you see contours. You may get a different color. If you want to change the colors of your contour, you can double click on the colors and you could change the color. Once you have this, we will open up AutoCAD Civil 3D. So go ahead. Oh, one more step before we open up AutoCAD Civil 3D. We need to create a DWG file. So let's select CAD. We want to be able to export to CAD. So the third one down, the features that we're exporting is contours. We're going to save this file in our specific window we've been saving it, and we're going to call this the Arroyo Seco Contour DWG, and hit OK. It'll take a few minutes, and while that's happening, you'll see that it produced something, and you could turn off everything else, and you could just see this is the CAD file it created. So here's the CAD file, and here's what the contours look like. So you can see what the CAD looks like. Go ahead and save your GIS if you want, so you could utilize it again in the future. And you could call this the Arroyo Seco file. You can go ahead and close out because we're no longer working with this. We're going to go ahead and open up AutoCAD, and we want AutoCAD Civil 3D, and we want it needs to say Civil 3D 2019 Imperial. This may take a few minutes to load, and while it's loading, remember where you've saved your file. So once you're inside of AutoCAD 3D, you will have some things pop up that are going on in your file. It's not a problem at all. I'm just moving this over since it was kind of taking over space. I want to go ahead and open my file. Up at the top you'll see Open File. And I'm going to go ahead and open my Arroyo Seco drawing file. It's saying that the drawing is in something else. Are you okay? Just say continue, and now it's opened it. What we are going to do is create a surface. So make sure you open your Prospector tool space. So you might be in Settings. Make sure you open up Prospector and create Surface. We're going to right click on Surface and create a surface. Let's call this Surface. Everything else is fine. We're going to hit OK. What you'll notice is you have a plus sign. Then you have it called Surface. You'll see that there's definitions. We want to open up definitions. We're going to create this surface from our contours. So we're going to say yes, let's add it. Our description is Arroyo Seco contours, and we're going to say OK. What you'll notice at the bottom in the command line is it says to select your contours. So let's go ahead and select all your contours. There should be 787 for this particular site. Hit enter, and now it is working on creating the surface, as you can see at the bottom. If you notice an outline, it's created a surface, but you cannot see the surface. So first thing I'm going to have you guys do is go to the Home tab, and we're going to go ahead and freeze the contours. That way we can see the surface when we place it in here. We're going to go ahead and go to our settings, and we're going to go under Surface. We're going to go under Surface Style, and we're going to go to Standard. We're going to right click on it and click Edit. The first thing we're going to do is we're going to create contour elevation, our minor and our major. I'm going to make them 5 foot. The next thing is I need to display them. So I'm going to go to Display, and I'm going to turn on my major and my minor. Hit Apply and hit OK in a minute. And now you have just created a surface from the USGS data. And if you have any questions, feel free to email me at Shah-Fairbank@cpp.edu.